Hello everyone, we are going to see a topic that is the interference of light. Here in this topic we will see its qualitative explanation. We are knowing that this interference is one optical phenomena. This optical phenomena is same as the other phenomena: reflection, refraction, diffraction, polarization. Same like that, interference is the phenomena of light. This interference is basically, it is formation of constructive interference, that is the bright fringes, and destructive interference, dark fringe, due to superposition. Position of two or more than two waves in medium. So it must be clear to everybody that interference is formation of constructive interference and destructive interference. Constructive interference refer to bright fringes and it refer to the dark fringes. The principle that is involved, that is the superposition of two or more than in the medium. So the principle involved in this case is principle of superposition. So it becomes very important to understand the principle of superposition here. This principle of superposition is referred to the when two or more than two waves travel in medium simultaneously. The resultant displacement of medium at any point, each point at resultant displacement at each point is equal to vector sum of their individual displacement. Mathematically, one may write resultant displacement of resultant y is equal to y1 plus y2 plus y3 and so on. So either 2 or more than 2 so by this the interference speaks constructive interference, destructive interference by the principle of superposition. Now see, there are some conditions the condition the interfering wave must have same frequency, and the phase difference between both must be same or constant throughout the experiment with respect to time. And minimum 2 is required. So for that, coherent sources is required. Coherent source produce same frequency and constant phase difference with respect to time. Can be seen here in the diagram. See this diagram very carefully. Let us consider a wave here. This wave is, seen it, a plane progressive wave traveling in one direction. This direction is here represented. A wave traveling along x-axis, their displacement, maximum displacement is given here a1 in this direction. First wave, their displacement. Same time, the second wave is also here given. Second wave y2 is in this direction, same direction traveling along the first wave. See, consider the second wave just over the first wave. The medium particle, see here, how will resultant wave will form and how medium particle will displaced from the mean position. This green line is for the mean position. If this is a situation, then it is said that both wave is in exact same phase. When they are in same phase, then both combine by principle of superposition and the resultant wave will form here. See, this is the resultant wave, how it formed. For the resultant wave, these two waves, when it's meet, their resultant displacement becomes like this. If A2 denotes the amplitude of the second wave, in that condition the total amplitude becomes A1 plus A2. Similarly, the complete wave becomes like this. Intensity increases, resultant amplitude A becomes A is equal to A1 plus A2. This A is called A max, maximum value here, and this phenomena is called constructive interference. Phenomena of constructive interference is obtained. See, these two waves having same frequency, constant phase difference, which is given the condition for sustained interference, same frequency, constant phase difference. When this occurs, and with that same frequency, same wavelength of both, constant phase difference, and one more condition, if they meets in exact same phase, constructive interference, that is the position of bright fringe, is obtained. In that condition, at exact phase A is equal to this A1 plus A2 and intensity becomes maximum. It is A1 plus A2 whole square. Now we want to see the second case for destructive interference. Destructive interference is obtained when interfering wave meets in exact opposite phase. See, what is exact opposite phase? Exact opposite phase is like this. This, consider the first wave. Traveling in the direction of x-axis with maximum displacement, that is amplitude A1. First wave y1 is here. Let us see y2 also. For y2, they are meeting in opposite phase. Opposite phase refer to this. It is like this. These two waves, their amplitude is A2 here. Now see, this is the beginning wave. Actually this box is for the second, that is the destructive interference. It is moving upward and second wave is downward, right? So medium particle want to move in upward direction due to the presence of first wave, and due to presence of second wave they want to move downward. If you consider the concept of Huygens principle here. So when they superimpose, mix up and new resultant wave will formed upward, downward, a resultant wave is formed here. In that condition, no change in frequency, but resultant amplitude is A1 minus A2. So this resultant amplitude here, when they meets in exact opposite phase, is known as minimum, and it is equal to A1 minus A2. Due to decrease in the amplitude likely to 0, the intensity of at this point is known as a minimum intensity, and this is a square of that we know, so square of this minus this, so minimum intensity is formed here. That is why dark fringes is formed. This exact same phase, when they are meet this situation, when phase difference delta phi is either 0, no phase difference, or 2 pi, 4 pi, 6 pi, if this phase difference and so on occur, it is said meeting in exact same phase. Resultant wave, their amplitude is a sum of both maximum intensity, constructive interference. But if phase difference delta phi, if it is like this, here upward, downward, it means there is a phase difference of pi. Same situation occur when it is phase difference of 3 pi or 5 pi, 7 pi phase difference, and so on. At this condition, if this phase difference occur, then it is said that they are meeting in exact opposite phase, and resultant wave, their intensity becomes differences of both. So minimum amplitude, minimum intensity, that is called dark fringe. As a result, how bright and dark fringes were formed. See carefully here to see the concept of it. let it is bright fringe, and we take suppose it is completely dark represented by shadow, dark fringe, opposite phase, then bright fringe, then again dark fringe, then again bright fringe, dark fringe, again bright fringe, dark fringe, bright, dark. As a result, alternate bright, suppose here dark, bright, dark, bright, dark, bright, dark, bright, dark, bright, and so on. The fringes is formed by this position. So I hope you are able to understand the qualitative mean of interference. That is formation of constructive interference, that is the bright fringe, destructive interference, that is the dark fringe, due to principle of superposition of two or more than in the medium. And for this interference pattern, this is called interference pattern, there are conditions, same frequency, constant phase difference. It is obtained by if we are using source of monochromatic light. For that purpose, sodium lime is taken. As a result, the constructive interference and destructive interference alternatively obtained. So this is for a topic. Thank you and have a nice day.